In this presentation, I would like to discuss partial derivatives and partial differential equations. Before going into partial differential equations and partial derivatives, let us remind ourselves of ordinary differential equations. Ordinary differential equations are dealing with single variables. So imagine we have got a function y is equal to f of x that is drawn in the xy plane. On the x direction, we have the independent variable x, and on the y direction, we have the function of x. Now, the rate of change of function with respect to x is defined as df by dx. df by dx means that if we take a very small incremental step in the x direction, we will get a resulting change in the function f in the y direction df, and dividing df by dx will give us the slope of the curve at the point the slope of the line is shown by f dash x. In the multivariable world, we can pretty much do the same thing. So we take an example of a multivariable function which is dependent on two independent variables x and y. Thus, we can take a small incremental step either in x direction or in y direction or somewhere in the middle of x and y. If we take an incremental step in the x direction and try to find out the resulting change in the multivariable function, divide the change in function by the incremental step in the x, that will be equal to the slope of the multivariable function with respect to x. If the single variable derivatives are shown by d, then the multivariable derivatives are shown by this sign which is called as curly or partial. So in other words, we have in the multivariable world partial f by partial x, which is equal to f dash xy. And this f dash xy is the slope of the multivariable function with respect to x. We can do the same thing with respect to y. Let us now discuss partial differential equations. Partial differential equations involve functions or its partial derivatives. Like for example, we have this 2D partial differential equation shown as partial 4 phi by partial x4 plus 2 times partial 4 phi by partial x square partial y square plus partial 4 phi by partial y4 equal to 0, where phi is a function of x and y are independent variables, thus making phi as a dependent variable. We will now highlight some important concepts related to partial differential equations. The first concept is the order of partial differential equations. Order is actually the number corresponding to order of highest partial derivative in the equation. Thus, in this equation, the highest partial derivative is of the fourth order, which will make this partial derivative as the fourth order equation. The other concept is linearity. A linear partial differential equation is the one in which the dependent variable, that is the one which is being differentiated, appears only in a linear fashion. So in this example partial differential equation, we have the dependent variable phi appearing in a linear fashion. We can see that none of the term of the equation has got phi getting multiplied. Thus, if we multiply phi with any of the term over here, that will make this equation non-linear. Another important concept is homogeneity of partial differential equation. A homogeneous partial differential equation is the one in which every term only involves the dependent variable or its derivative. So in our example partial differential equation, we have only the dependent variable phi appearing in the equation. Thus, we can call this equation as a homogeneous partial differential equation. However, if we add independent variables as terms to the partial differential equation, then this partial differential equation will become non-homogeneous, such as x square and y square is added to the same partial differential equation, and that makes the whole partial differential equation as non-homogeneous. Another concept is the coefficient types. In this equation, our coefficients are constant. So in the first term, we have a constant coefficient 1. In the second term, we have constant coefficient 2. And in the third term, we have constant coefficient 1. We can also have variables such as x and y being multiplied with each term. In that case, we would have the coefficient type as variable.